This recording is going to go over vertical circles. It's when we started swinging a bucket where we were swinging it up and down. What we did before were horizontal circles where we would kind of focus on the lasso style. And so this would be lasso. This is what we've called horizontal. But this is where we're swinging up and down. And here's what we're going to look at. We're going to look at why the bucket appears to feel light on the top and heavy at the bottom. And here's what we know. As we move our arm in this circle, and if I draw this a little larger here, we know that at the top and at the bottom, these are the two primary points. We should know by now that there's always a centripetal force pointed inward. So the centripetal force here is always inward. So at the top it's down, at the bottom it's up. Well, what we're going to learn is this. The centripetal force is going to equal the force of tension. This is what we feel. We feel the force of tension. So this is key here. We feel tension. And at different locations, we'll talk about what's happening with the object's weight. So here's what we know. We know that the centripetal force is going to equal the force of tension plus or minus the weight of the object. So let's say that we have a bucket. So I'm going to get right into this little practice problem. Vertical circle. Let's say that the bucket at the top, well, let's say the bucket in general. Let's say this bucket here. Let's say it has a weight of 3 newtons. And let's say that so that's its weight. Let's say that the amount of force necessary to keep this bucket in motion at all points, so we got these bucket top and bottom. Let's say it takes 12 newtons of a centripetal force to keep it in location, keep it moving in a circle. Remember, if there's a centripetal force, then a centripetal force is required to keep it moving in this circle. So now we can make sense of this because you're going to start realizing that we feel the force of tension, but it's going to feel heavier at the bottom and lighter at the top. Think of it this way: when you're providing centripetal force, it's down. Well, so is gravity. So you're going to get a little bit of a boost from gravity when the bucket's at the top. And when it's at the bottom, we need to make sure that we realize that you're pulling up and gravity is acting downward. So you're going to see that the magnitude is going to be larger. It's going to feel heavier at the bottom, even though it's not heavier. It's simply the direction of the forces. So here's what we know. We know at the top of this, the top up here, the centripetal force is going to be the force of tension plus the force of gravity, or in this case, the object's weight. So we're going to say, well, why does it feel lighter at the top and heavier at the bottom? So let's look at the top first. So we can ignore this right here. It feels lighter at the top, but I'm going to put quotation marks on it because nothing changes with its weight. Here's what we know. We feel tension. So force of tension, if I isolate force of tension, I can subtract weight from both sides. So F of C, well, if it takes 12 newtons of force to keep it in motion, I can determine that the force of tension that I feel is going to equal the centripetal force minus its weight. So the force of tension is going to be 12 newtons minus 3 newtons. It's going to feel like it only weighs 9 newtons at the top. Remember, gravity is providing you 3 of the newtons of the centripetal force. So it's only going to feel like you only have to apply 9. Whereas at the bottom, so I can ignore this part up here, if I isolate force of tension, remember that's what we feel. It's going to be the centripetal force plus it's the weight of the bucket. In other words, I've got 12 newtons plus the weight we said was 3 newtons. It's going to feel like, right, the force of tension that I feel is going to feel like it's 15 newtons, even though nothing changed. And in this case, we can see that it feels lighter because it's going to be both tension and gravity acting downwards, providing the centripetal force, whereas here you have tension and gravity acting in opposite directions. So remember, this vector component, these add together. Therefore, it feels like it's only 9 newtons at the top, and it feels like it's 15 newtons at the bottom. Therefore, it feels heavier at the bottom, and it feels lighter at the top.